Good morning, students. In this class we are continuing with the chapter electricity and magnetism, starting with the topic make your own magnet. Here we use the single touch method. We need two things to do this experiment. That is a flat piece of iron, rectangular flat piece of iron, and a bar magnet. As given in the diagram, arrange that. Place it over the table. The soft iron core should be placed over the table. And take the north pole of the bar magnet and rub it from point A to B 30 to 40 times repeatedly and continuously do it. And take out the bar magnet and place it somewhere, and take the iron bar, and we need to know whether it is changed to a magnet. So in order to know that, take a pin, steel or iron pin, and take it near to the iron bar. So we can see that the pin get attached to the iron bar. From this we can come to the conclusion that this while rubbing with the bar magnet, the soft iron core get the property of this bar magnet and change into a magnet. So it is not very strong magnet, it is a weak magnet. In this way we make a in this method we can make a weak magnet. Next is about the precautions while using a magnet. So magnet lose its property when it is heated or hammered it very strongly. So first precaution is never beat or heat it. Second one is for the protection of magnet, we need to kept it safe in particular way. That is, it should be kept in a wooden box. And two magnets are kept in one wooden box in such a way that in the middle of the two magnets keep a wooden block, and at the two ends of the magnet you should keep a iron rod. So this is the way of keeping a bar magnet safely. And if in order to keep a U-shaped magnet or a horseshoe-shaped magnet, protections should be like a steel plate should be placed on the ends of the horseshoe shaped magnet. So next is the laws of magnetism. So there are 7 laws of magnetism, and the first one is magnets always attract the magnetic substance. That is the first one. And second one is when it is suspended freely, it always points in the north-south direction. Third one, like poles repels, and fourth one, unlike poles attract. And fifth one, repulsion is the surest test to prove it as if it is a magnet or not, or it has a magnetic property or not. And sixth one, a bar magnet is rubbed over an unmagnetized piece or an iron or a steel or any kind of unmagnetized piece, it changes into a magnet. And the last one, if the magnet is heated or roughly handled, it loses its magnetic property. So these are the 7 laws of magnetism. Next one is about electromagnetism. So electricity and magnetism are interrelated. If you pass electricity through a coil, which is as given in the diagram, you can see in the diagram where a coil means coil of an insulated copper wire in the form of cylinder, which is also called as a solenoid. And in the solenoid, if you place a soft iron bar, or which shape we need to make, like maybe sometimes we need a horseshoe magnet, we can place a U-shaped soft iron core, or if you want a bar magnet, you can place a rectangular one. So in that way we can make. So if you place inside it, inside the solenoid, this soft iron core, and connect it to a battery and then to a switch, and on this switch the current start to pass through it. You can see as given in the diagram. When current pass through it, a magnetic field is produced in the coil, and if we place here we place the iron bar inside it, so this iron bar is in the field of it is in the magnetic field, so this iron bar becomes a magnet. So this is how we convert a iron into magnet. And if you want to make a permanent magnet, in the place of soft iron core, we can replace it by the steel or alnico. So if you place it inside, in place of the soft iron core, the steel get converted into a permanent magnet. But here if you are using a soft iron core, it only converted into a it's just a temporary magnet, where the temporary magnets means they lose the magnetism soon as the magnetic field is removed from it. So that is the temporary magnets. And permanent magnets means which do not lose its magnetism when the cause produced them is removed. That is called as permanent magnetism. Next is about some of the uses of electron. There are many uses of the permanent magnetism. Some of the uses we can discuss here. The first one is it is used in many of the electronic devices like telephone, electric bell, loudspeakers, electric motor, generators, etc. And next is it is also used in television for deflecting electron beam in the picture tube, and also it is also used in the they are used in magnetic separations of iron ores. Iron is having a magnetic property, so if you want to separate it, we can use this electromagnet. And then also to make strong permanent magnets using steel and alnico, we can make permanent magnets. And also it is also some doctors by doctors to cure some diseases, they are using this magnet. And also in the MRI scan, maglev trains, so etc. It uses the electromagnetic property. And this electromagnetic property, the strength of electromagnet can be changed, or it can be varies according to two things. The first one is if you increase the number of turns in the coil. If you increase the number of turns in the coil, we can increase the strength of the magnet. So that is the first one. And second one, if you increase the more current flowing through the coil, if you pass more current through the coil, then also we can increase